What's up, guys? Welcome back to the channel. In this video I'm going to be showing you the basics of welding, what welding is. We're going to talk about the three main processes and which process would work better for you, because each process, there's different types of repairs and jobs that each process will be the best for. And with this basic information, that will help you start off making better welds and also help you select what process works best for your needs, and then also which machine you should purchase first. But do me a favor, hit that like button, hit that subscribe button. Let's get started. So again, guys, this is just going to be the basic information, laying the foundation of knowledge that you'll need to get started welding. There's going to be a lot of information that I'm going to share in future videos. We're going to go more in depth on other videos. So I'm going to try to explain it in very simple terms. So we have a battery right here. I have this black cable hooked up to the negative terminal, and I have it hooked up to this metal table here. Positive terminal hooked up to the red cable here. And so we all know what's going to happen if I touch this to the table. We're going to create a spark. So basically, welding is very similar. You're completing a circuit and you're using an electrical arc to melt the metal. So just like that battery, we have, the welder has a negative cable here, or ground lead, hooked up to the table, and then we have a positive. And right here, we're hooked up to a stinger with a stick rod in here, otherwise known as an electrode. Now this is for stick welding, otherwise known as shielded metal arc welding. So what would happen is, if the machine was on, we're ground here, and we're completing the circuit, and it would create an arc, and that arc is what would melt the two pieces of metal as well as this metal rod. But the welding machines are made to create a stable and smooth arc, maintain that arc, and you can adjust the amps and the volts depending on how much arc that you need to melt whatever thickness of metal that you're needing. So there's many ways you can weld, but there's three main processes. And all of these three main processes use an electrical arc to melt the metal and melt the filler rod, or what you're putting into the weld. Okay, so there's three main processes. Number one is stick welding, which is shielded metal arc welding. MIG welding, which is gas metal arc welding. And then TIG welding, which is gas tungsten arc welding. Notice they all have arc. Now another thing each process needs to have is, when you create an electrical arc and you're making that puddle of molten metal, you have to keep oxygen out of that molten puddle. Now it's done a couple different ways. With stick welding, it's using a flux on that rod to create little explosions to push away the atmosphere, and it protects that molten puddle from oxygen entering into the molten puddle and ruining the weld. With MIG welding, you're using, and TIG welding, you're using an inert gas that is shielding that puddle as you're making the weld. So first, let's take a look at shielded metal arc welding, otherwise known as stick welding. This is called an electrode right here, and there's all types of different sizes. We'll get into that later, what the numbers mean and everything else. But basically, it's in a metal rod that's covered with this white powdery substance. Like here's one that's, you can see the metal rod and this powdery coating here, coating that rod. That's the flux, and that's what's burning away as you're making the weld. And if you've ever seen stick welding being done, you'll notice all that smoke, you'll notice splatter, but that flux is burning away to shield that metal from the outside oxygen. And this is also known as a consumable electrode, otherwise, because it's consumed into, as you're welding, this rod gets shorter and shorter because it gets consumed into the weld, and that rod becomes the filler. Like if we were to weld these two pieces together, we have a slight gap there. This is going to fill in that gap, as well as the arc is melting both pieces of metal melting the rod, and the rod is filling in that gap and fusing into both pieces. Now with MIG welding, instead of using a rod, you're using wire. It has wire that comes out, and you can select the rate at which that wire comes out. And it'll be on a spool inside of the machine. So when you pull that trigger, it does three things actually. It's creating the current, completing the circuit. So when you pull the trigger, it's going to start, it's going to complete the circuit to create the arc. It's going to start feeding the wire motor here to pull this spool and feed it all the way through the line. And it's also opening up the solenoid to let the shielding gas also comes through that line and comes out around this nozzle right here to shield the puddle. So this wire is basically taking the place of that stick in stick welding. All right, guys, so let's talk about the advantages and disadvantages, or in other words, when you might want to use what process for whatever type of application. All right, so with stick welding, one of the main benefits to stick welding is that you can do it outside because it's burning off that flux. You can be in very windy conditions, and the puddle is going to be protected by the flux. Like I said, creating basically little microscopic explosions going on, pushing away all the wind and everything. As opposed to like MIG welding, if I was MIG welding here and I have that shielding gas coming out just around that nozzle, wind can easily blow the gas away. Oxygen enters into the molten puddle and ruins the weld. Now with MIG, you can run what's called flux core wire, but we'll get into that in a little bit later. But another advantage to stick welding is that you don't need a shielding gas. You don't need a bottle, so the setup is very easy. You just need the welding machine, welding leads, positive and negative, welding rods, very simple setup. Another good advantage to it is that it will weld it'll weld thick materials relatively easily. And depending on what type of rod you're using, you don't really have to prep the metal nearly as much as, say, for like TIG welding. TIG welding, you have to have that metal really clean. Another good advantage to stick welding is you have very good visibility. Nothing is blocking your view when you're welding here, as opposed to like a nozzle on the MIG welder. Some people might, as you're creating that puddle, the nozzle kind of gets in the way of your visibility of the puddle. Now, some of the disadvantages to stick welding as opposed to MIG welding and TIG welding is that it's much harder to weld thinner material, all right? And then you also have a lot of splatter, smoke, where you still will get splatter and smoke with MIG welding, but not nearly as much as with stick welding. Now the skill level for stick welding is probably about, I would say, in the mid-range. MIG welding is really easy to learn and really easy to do, where TIG welding is probably the most difficult and skill intensive of the three processes. Another con to stick welding as opposed to MIG welding is that it's harder to get, start and stop, stabilize that arc, where with MIG welding, you can just start and stop really fast. Here's an example of what I'm talking about, how easy it is with MIG welding to start and stop. As I'm tack welding into this expanded metal into this box I'm building, I can easily start and stop, no fuss. All the welds are really predictable with, where if I was TIG welding this, it'd be a very much slower process. Stick welding the same, it'd be hard to start and stop those arcs and maintain that arc, but with this MIG, it's just so easy. Another disadvantage to stick welding as opposed to MIG welding is, as you consume these electrodes, you have to stop, change them out, because you only have so much distance you can go before that whole rod is consumed. But with MIG welding, you just have that long spool and you're basically limited to the duty cycle of your welder. Now with MIG welding, like I mentioned before, when comparing it to the stick welding, it's very easy to learn how to do. It also makes really clean welds, nice looking welds, low splatter, low smoke, continuous flow of filler metal. You have a long range of welding. You're just limited to the duty cycle of your welder. Fast and easy starts and stops. You can just sit there and tack, 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 weld, stop and start again really quick. But another good advantage to MIG welding as opposed to stick welding is you can build up and fill in gaps much easier as opposed to stick welding. It's a lot harder, it takes a lot more skill to do. But with MIG welding, you can just like sit there and build up, and weld as you need. Now the disadvantages to MIG welding is you're limited to how much wind you can have blowing. Like even if you're in a shop, you can't really have wind blowing on you, or at least not on the weld. That's why I often have I have an air conditioner underneath this table that will blow cold air on me, but it doesn't get on the weld. You can't have any wind blowing away your shielding gas. And also with MIG welding, because you got that nozzle and that gas coming out, you're sometimes limited to your visibility on the weld puddle. Another thing is it's much more expensive as opposed to stick welding, because you have to have a bottle regulator, so it requires a lot more setup. So now let's talk about TIG welding. And guys, TIG welding is very fun, but it requires a lot of skill. It shares a lot of the features of stick welding and MIG welding. Every TIG welder can be a stick welder. As you can see, we have the ground, we have a rod, and we're creating an arc with a torch. And that torch is sharing the gas, shielding gas, kind of like the MIG welder, but you're having to manually put in a filler rod by hand. So oftentimes you'll have three different things going on. You're looking at the arc, so you're controlling the torch with that non-consumable electrode with the tungsten, and that's also providing the shielding gas. So you got that going on with one hand, filler rod with the other hand, and then you have a foot pedal that you're controlling the arc. TIG welding produces very precise welds. You have a lot of control over it, the speed, you can just see everything really well. Very clean welds, very low smoke, practically no splatter. It's great for like thin materials. It's great for doing all types of metals, especially like aluminum. The disadvantage of it is it takes a lot of skill to do it. It's a slow process. It's also an expensive process. TIG welding can be an expensive process because you're going through a lot of the shielding gas as you're welding, and it's a slow process, so that's why you're going through a lot of gas. You'll go through a lot of filler rod. Tungsten's very expensive. There's different tungstens that you need based on what you're welding, different shapes of the tungsten on the end depending on what you're welding. So TIG is probably not going to be as the process for most of you. Basically, most of you will probably need MIG or stick will better suit your needs, but we'll get into TIG welding. I did have an Eastwood TIG welder. I think it was the Eastwood TIG 200. It was around $800. It was a great machine. I just rarely needed it. I only used it maybe once or twice a year and ended up selling it. And when I got this Multimatic 215, it's capable of doing TIG. I just don't have the setup for it yet, but I'm going to get that soon when I go and get into the TIG videos. But first I'm going to get into more of the MIG and stick videos first. Alright guys, so I want to do a little experiment and show you a couple of different things. We're going to do some stick welding on these. These are 2 1/4-inch thick plates, and I have a 1/16 inch gap on each one of them. First thing I want to show you is the difference in the smoke and splatter between MIG and stick, what the welds are going to look like. Then also what I'm going to do is I'm going to stop halfway through, and then I'm going to add some wind. So then I will continue on with the stick weld, and then I'll continue on with the MIG weld with some wind blowing through here. Now I have each one of these tack welded down to hold it in place, because as you weld, it'll kind of, you know, pull and draw the metal in. So I've got them tacked down so you guys can see them really well here. But first, let's go over like proper welding gear that you're going to need. First, you're going to need a welding hood. They have different types of hoods, some that have just a fixed lens that you have to flip down. I like this. This is what's called like a blink hood or auto darkening helmet. I like the Clutch brand, pretty good bang for your buck. Now I would recommend a number 10 in shade. Now 10 is the level of shade, 11 would be darker, 9 would be lighter. No matter what welding you're doing, I would recommend at least a 10. Now with these auto darkening hoods, there's only so many strikes or arcs, because you know it's not quite as fast. To the human eye, it seems like it does it instantly, but there is a little bit of light that will hit your eye. So depending on the manufacturer, they'll say only do about 300 arcs or starts per day with an auto darkening hood. All right, next up, you want to get like a welding cap such as this. They're just funny looking caps. They call them engineer caps or welding caps. Now they're made to where you can actually put it over to the side, and if you're welding, splatter won't get into your ear. But it also just, you know, helps absorb sweat, makes it more comfortable. Next, get some good welding gloves made for welding. There's different styles. The thinnest ones are for TIG welding. It gives you lots of movement with your fingers. Then they get thicker with MIG welding, and even thicker with stick welding. Next, you want to get like a welding jacket or a long sleeve shirt or something. You mainly want to protect your skin from that UV light coming off of those welding arcs. It's very dangerous. It's far more intense than sunlight. It's not only just to protect yourself from the splatter and things, it's mainly to protect your skin. So you want to make sure all your skin is covered. One extra thing, guys, I failed to mention as I'm editing this video about the light. Wear black t-shirts or dark colored shirts if you're going to weld in a, just say like a long sleeve cotton shirt. Don't wear white or light colors, because basically that absorbs the light and reflects it right onto your skin. Wear a dark color, dark blue, dark gray, or black, because that black cotton will absorb the light and not reflect it onto your skin from the light. So you can do leather, or you can do flame resistant cotton, which is what this jacket is made of. And then next, I would recommend jeans, and then some leather boots, some good leather boots. I prefer Red Wings, and I prefer steel toe. All right, so let's get started here. First, I'm going to do a pass with the stick, and again, I'm going to stop halfway, and then I'm going to do one with MIG. Then we're going to add in some wind and show you what happens there. So right now, let me get set up for stick. Another thing with stick welding, you want to keep these rods dry. And a lot of times they make ovens, and a lot of times before a job I would actually put my welding rods in the oven to dry them out really good. Welder set up, I'm using an 1/8 inch rod, 70/18. 124 amps, 1/4 inch. Now these 70/18s have a really heavy layer of flux that lays down, but what's good about it is this is relatively quiet and low splatter for stick welding. So I think I got it all set up, so let's go. So I've stopped about halfway. Now I'm going to set up for MIG. Got the gas on. And also with MIG, you want to make sure this these nozzles will get kind of clogged up with splatter and stuff, and you want to kind of keep it clean. Take like a wire brush or get into those pliers. Don't hit it. Don't hit your MIG gun against. That's what I see a lot of guys do, and eventually you're going to damage the MIG gun. And with MIG welding, you want to keep that nozzle relatively close to let that shielding gas do its job. There's the MIG, there's the stick. Now this is covered with flux right now. So there's the stick weld, there's the MIG weld. So now let's add in some air and see what these welds look like. All right, so now I have a fan blowing just a little bit of air across the weld. It's going to be enough to mess up this MIG weld. I'm going to show you guys. So I'm going to go ahead, since I'm already set up for the MIG, we'll go ahead and do that now. And that weld is pretty much ruined just because of that airflow coming across here. Blew away the shielding gas. But now I'm gonna, with that same airflow going, I'm gonna continue on with my stick weld. Well, these 7018 rods, when you go to restrike, so there's a little flux coating on the tip that's isolating this metal. So what I'll often do is just scrape that off. So now I can get to bare metal and get a good arc. It helps you get a better start. So we got the wind. Actually, I'm going to crank up the air just a little bit more. Let's continue on here. So you can see, even though I increased the airspeed, that weld doesn't have porosity like the MIG weld does. All right, guys. So I hope this video helps you out, and you can probably see why what process you might need. Let's say if you're a farmer and you're needing to do out in the field quick repairs on a trailer, farm implement, things of that nature, most likely stick welding is probably going to be the process you'll need, because you're probably going to be dealing with thicker metals, outdoor conditions, windy conditions, and probably not going to have the ability to kind of clean the material and everything. So a 6011 rod, 7018 rod would probably be good for you, and a stick welder. You can get an engine-driven welder, so you have that good mobility. You can carry it in the back of your truck, side by side or whatever. But if you're planning on doing welds like on your car inside of a garage where you can control the wind conditions, MIG welding or TIG welding might be the way for you. I would lean towards MIG welding if you're going to do a lot of production work, just really fast. You want to be able to do a lot of welds, go from here to there, or long welds, and MIG is relatively less expensive than TIG, and it's really easy to do. You could train other guys how to do the MIG welding a lot easier. Or if you're going to start building some products, mass producing some products, MIG welding is probably the way to go. One other thing I wanted to mention is if you wanted to get a MIG machine and you do run into the need where you need to do like some outdoor welding in the windy conditions, you can run flux cord wire. So basically, you can see like basically like on this little illustration, the flux is inside of that wire. So it pretty much is just like stick welding, but with the MIG process, and you don't need a bottle, and you don't even need that nozzle on the thing on the end of your MIG gun, and it creates a lot of splattered smoke just like stick welding. So there's an option though. That is an option if you want to do some outdoor windy condition type welding if you decided to go with a MIG machine. And like my Miller Multimatic 215 here, we'll do all three processes. So could switch from stick welding right here simply by twisting this out and putting in my connection there to my MIG, and then I can select what process I'm going on right here, and it'll also even show you some parameters. It kind of has an auto set feature. So right now I've hooked up to my MIG and it already senses that there's a cable error. So I would select up here to go to MIG, and that's depending on if I'm running 100% CO2 gas, but I'm running 75 to 25%. We'll get into the gases and stuff later. So I'm set up correctly now, and it will show me if I wanted to turn on the auto set, I could select the size wire that I'm using and the size material that I'm using, and then I can kind of make fine-tune adjustments, lowering or increasing. But no matter where I'm in, I'll be within a weldable range for that thickness of material. If you're needing to do like really thin, very meticulous welds, aluminum, or pretty much you can weld any material with TIG welding, but we'll get into the polarities too, because you need to be able to do with aluminum, you need to be able to weld on AC, not DC. DC, you're only limited to carbon steel and stainless, but to do aluminum, you need to be able to run on AC, alternating current. So anyway, I hope this video helps you guys out. This is just kind of like the basic introduction, basic info, a little bit of demonstration. Hopefully this info will help you guys out if you're wanting to get into welding, what you need to get as far as safety gear, what machine, what process. And I'll be doing more videos kind of diving deeper into each process. And I'm going to be doing a lot of videos on cutting, grinding, things of that nature, bending. And there's just going to be a lot of videos I want to make here pretty soon where welding is going to be involved. All right, so do me a favor, hit that like button, hit the subscribe button, and I'll see you guys next time. Thanks for watching.